If you want to make money in the fire alarm industry, learning how to program a fire alarm panel will definitely get you there. Now, there are many different manufacturers on the market like Simplex, Notifier, Siemens, and also Edwards. But for this video, I'm going to show you how you can write rules for the Edwards system. This is more specifically for the EST2 and the EST3. I have not worked on the EST4, but if you have your questions, we can chop it up in the comments below. So let's get straight into this presentation. Thank you for joining me. Here we have the introduction of the EST3 fire alarm control panel and its programming capabilities. By the end of this video, you will learn what a rule is, how to write a rule, what the input side is, what the output side is, what the syntax are, and how to actually compile and download to the fire alarm control panel. But before we get into this, let me explain a little bit about who I am. My name is Anthony Richardson, and I am the president of Securities. We are a licensed fire alarm and security company here in New York. We are licensed to install and maintain fire alarm and security systems. I've been in the business for about 25 years, working with Local 3 and a lot of the larger companies like Simplex, that is now Johnson Controls. I started my business about 13 years ago. We put in about 40 fire alarm systems since then. So let's get straight into this presentation so that way I can make you guys fire alarm experts. So to understand the rule, you need to understand what the basic rule structure is. You have the rule label, you have the input statement, followed by several output statements. You could have a couple different output statements to activate all at the same time, relatively at the same time, because the rule equation actually works from top to bottom. So you can turn on horns, you could turn on strobes, you could turn on fans, and you could also recall the elevator. So you could have multiple different things happen on the output side. So this is what a general basic alarm rule structure looks like. Inside here where we have gen_alarm represents general alarm. This is your rule label. You need to have the brackets. You can't go more than 40 characters with inside this label. If you don't have the brackets, then your rule will not compile. On the input side, you have alarm, smoke, underscore, wildcard, semicolon. And we also have these guys here on both sides. Not quotations, not exactly sure what these are. You can let me know in the comments what these guys are. But inside here is what your device type. Smoke, pull, whatever you want to go into alarm, that device type will be here. Now, the next thing after that, you will have your colon. Your colon will separate your input side to your output side. And on your output side, you can activate multiple things. Here, we're activating a speaker on the 8th floor, strobe on the 8th floor, and we're shutting down the fans. On the right side, we have, it's explaining what this circuit is, and you have your French brackets, your open French bracket and your closed French bracket. So anything inside of the French bracket, your notes, there you will want to put your information about what this rule is actually doing. The system will literally ignore this when it's actually trying to compile. So if you don't have your French brackets and you have notes, the system is going to look at it and look for syntax, and it's going to give you an error on the output side. For you to further understand what this wildcard is, let's say we have 3 smoke detectors. There's a label side and then there's a message side. I'm going to go into the program to further explain this so that way you can see and understand why they do it this way. But if you worked on any other type of fire alarm system, the input side would be M1-1 or M1-2. This would be the actual address of the smoke detector or whatever device you're trying to control. But for Edwards, there's label text and then there's message text. The message text is the actual device location, 3rd floor, electrical room. So the label text will be how you will write the rule for that specific smoke detector or for that specific device type. Like I said, we have 3 smoke detectors. It will be smoke_1, smoke_2, also smoke_3. So we can only write one input equation on the input side, and we can't write smoke 1, 2, and 3. So what we do is put the wildcard to represent 1, 2, and 3. So we know smoke_wildcard to represent all of the other different smoke detectors. Not to confuse you, you could have put *_*, and anything that has that label structure will be added to this input rule equation. But you wouldn't want to do anything like that, because you want to just say when the smoke detector, specifically a smoke detector on the 8th floor, go into alarm, I want to turn these speakers on, I want to turn this strobe on, and I want to shut down the fans, either on a specific floor or throughout the building. And this looks like a voice system. This would be like in a high-rise system. And usually in a high-rise system, you would have to activate 3 floors, sometimes 4 floors, depending on the AHJ. But 3 floors would be the fire floor, the floor above, and the floor below. And to do a little bit of advanced programming, you would turn on the inquiry tone throughout the rest of the building. So here are some of the rule components. Like I said, this may be redundant, but you need to understand that the rule label needs to be unique and identify what the rule is actually doing. If it's a general alarm, if it's a smoke elevator recall rule, if it's a pull station rule, whatever the rule is doing, you should identify that in a rule label. Then you have your input side, respective of the syntax and the colon that's going to separate the 2 statements. And now your output side. And I didn't explain this, so let me go back. On the output side, like I said, I have no idea what these guys are in between on the outside of speaker 8. Let me know in the comments. But if you write in multiple outputs, you want to separate your outputs by commas. Each output gets separated by a comma, and that last one, or the final one, will close the statement off with a semicolon. So when you create a basic rule, you define the label, you write your input statement, respective of the syntax, you write your output statement, your multiple statements, respective of the syntax, the commas, and the closeout statement of the semicolon, and then you compile it. What compiling does is taking the words that we see, the characters that we see, turning them into 0s and 1s. So when you download it to the CPU, the computer understands what you're actually trying to get it to do. And when it comes to the output statement activation, when the rule actually goes true, the output statement starts from the top down. And when it restores from the bottom up. Whatever you want to turn on first, you would actually label that first. So that way you wouldn't notice it realistically when the system is in alarm. It happens instantaneously. You really wouldn't notice no type of delay. However, whatever you want to activate first, you want to list that off first. Usually the horns and strobes, usually maybe your amplifiers, whatever you want to activate first, you will put that on your output statement first, on that first line. So some of the best practices you can use when writing rules, you want to use clear, concise labels. So if you have general alarm, like the example before, you want to put gen_alarm, or you could just put general space alarm. The underscore represent a space. So you cannot have any empty spaces inside of the rule program. And that is the reason why they use underscores, because an underscore is a character, space is not. So that's the reason. Once you add your comments, make sure you got your French brackets. Make sure you have all your proper syntax, your semicolons, your colons, your commas, and things like that. And then you test it, you compile it. Once it compiles, you'll get a completion. It'll let you go, it'll build up all of the loop controllers and things like that. And then you're able to download to the system. So some of the mistakes that you could make when writing these rules, and with the Edwards system, there's a separate program called Gens Editor. And what the Gens Editor do is that it'll help you, or rather it'll color code the rules so that way you know when you're making a mistake. If it's blue, then it's good. If it's red, then you have a mistake somewhere in that line and you have to fix it. I don't use the Gens Editor. I've been writing this for over 20 years, so I kind of understand what I'm missing. However, there is eye fatigue, and you could mistake a semicolon for a comma or a comma for a semicolon. You could have some type of typo somewhere, and it's so small and minute, and you got that fatigue, it's hard for you to determine what it is, right? So also you want to remember that when you're putting in your notes, especially if you're one of those tech geeks that want to be doing all these tricky programming things inside of the rules, just put your notes and make sure you got your open and closed French brackets. So if someone's coming behind you, they know what the hell you're doing. And your incorrect object label formatting, those are like typos. So if you write something out speaker and then you go into the rules and then you want to abbreviate it, you can't do that. You got to write the word out as you wrote the object label. So here's some examples of a rule. Of course, we have our rule label, we have our input side, and then we have our 2 output activations with our syntax, comma, and to close it out with a semicolon. And we have a disable output activation right here. We have an example of how we could disable the outputs. Usually in a high-rise system or in high-rise building, we will disable the outputs for testing purposes. So if you have a high-rise building with multiple different elevator banks and you test the elevator smoke detector, you're gonna drop all the elevators. So you don't wanna do that. So if I'm testing a system, I will hit this output, turn off all the output activations, the horns, the strobes, the relays, so that way nothing will activate on the output side, and then I can do all my input testing. And for me to verify the output side, to schedule with the building owner, whomever you have to schedule it with, to maybe do it off hours or over the weekend and verify elevators, fans, and the horns and strobes, or if you're working on the voice system, make sure the messages are there as well. So when you're compiling and uploading the rules, like I said, it's taking the characters we see and turning them into zeros and ones in which the computer can understand. It's going to verify that you don't have any syntax errors. You're going to make sure you have all your French brackets if you're using notes. Then once that's done, it'll get complete compiled. You may get some warnings, maybe some labels and things like that. Then from there, you connect to your CPU and upload all of the configuration changes to the fire alarm control panel. Finally, you test, make sure if you test in the elevator smoke detector, the elevator's recall. However, if you don't have any controllers connected to your relays, your job is to make sure the relay actually change state. So if the alarm goes off and something is connected, supposed to be connected, normally open, that relay should close. So you put your meter on it, test for continuity, and if the meter beeps, then that continuity is there. The relay will activate and the alarm is safe to say, yeah, it's gonna work, whatever's connected to it. So if you, like I said, if you have any questions, let's chop it up in the comment sections. And just to recap, what we went over was understanding what a rule is, the rule label, the input side, the output side, the syntax, what separates the two, and how it compile it. So before we close this out, let me just go inside of the EST3 programmer and let me show you what this actually do. So here we have our rules. And if you have not went to training, you won't even be able to even work on this, because once you pass the training, you'll get a software key that will connect to your laptop so that way you can run this actual program. I'm not sure how the EST4 is, so please don't ask me no questions on the EST4, I don't know. So inside here, you see here we have our French brackets, our open and close French brackets explaining what this actual program is doing. We have our rule label, which is general alarm, and then we have alarm with those two brackets with the star, the asterisk star in the middle. Let me explain real quick what's happening here. Inside the object label, this is representing the label text. That star is representing the label text. So we have the label text and we have our message text. Like I said, the message text is our exact location of where the device is actually located, and our label text is how we can manipulate each different point type. So you see we have, all of these are smoke detectors, but these smoke detectors are doing different things. Some is in front of the elevator and some are not. Some are just area smoke detectors and some are just in front of the elevator lobbies. So the ones that are in front of the elevator lobbies, you want to identify those differently than the ones that are just area smoke detectors. Reason being, this is gonna do one extra step, and that extra step is activate that elevator recall relay. So that star is representing all of these characters, smoke _1 _ elevator 1 main, smoke 4 all the way through 14. That asterisk star is representing that, is representing all the labels for the pulls, represent all the labels for the water flow. This is a generic way to make anything that's an alarm point type activate. So you can write one rule if you have multiple device types and anything will work. So now let's go back to the rules. So you see we have our separator, which is our colon, and then we have our rule output, which could be multiple outputs. And we have the commas that separate each output, commas separate each output, and to end it off, we have our semicolon. And like I said, I have no idea what these quotes are here. Let me know in the comments. So inside here, we're latching on a fan relay, because for sake of argument, let's say if you have 30 fans in the building, you wouldn't want these fans to all start up as soon as you hit system reset. In addition, the fans are not supposed to even start up when you hit system reset. So this latch is telling the relay to stay active even when I press system reset. So that way I have to press the secondary button, which is the fan restart button, in order to activate the fans. Now, if you have multiple fans, each one will have a delay because it just pulls too much power if you have 30 fans all starting at the same time. So you will stagger each one 5 or 10 seconds apart, so that way they can start in succession and doesn't drain all the power within the building. Then you have, we're turning on the door release. The NSO is for non-supervised output. So these relays are not supervised with a resistor, so we wouldn't know what happened to the wire. We would only know what happened to the module if it loses, it goes into ground fault, or if it loses communication. Then we're turning on a damper relay, turning on the city tie trip. This city tie is an old school way to connect to the central station, like when they had the McCullough system. This is a direct connection to the central station. And we're turning on the visible circuit for the horns. And Why they put it visible is so when I hit the alarm silence button, the horns will shut off, but the strobes will still flash. So we make it a visible circuit. They probably have Genesis horn strobes on this circuit. You can make it a horn circuit or a visible circuit, but if you make it a horn circuit, everything will shut off when you hit alarm silence. So that is a brief overview of how you can write a rule in the EST software programmer. This is relevant to EST2 and also EST3. If you have any questions, like I said, let's chop it up in the comments. I'm here to help you. I'm the fire alarm expert, and I'll catch you on the next video. Peace.